someone said it, but I didn't actually hear what you said. These all have common. So if we divide 2 out of everything, what's left? Here are the last two. What about the first one? 1k squared, and then minus 4k minus 45. Okay. And then we need two numbers that multiply to be 45, add to be negative 4. You should have found 5 and 9 to be those factors. 1 needs to be negative because 45 is negative. So k minus 9 and k plus 5 would be your answers to that one. If you have questions on that, we'll talk about that when we come back from lunch, and then we'll go over 2 more. So for number 20, what do these have in common? They are math problems. But what specifically do these 3 terms have in common? X. So if I divide each term by x, what's left? This one has 3, but I'm taking one out. How many are left?
1.
More than that? 2. And then for the second one, 2x squared divided by x would be what? It would be 2x. And then negative 48x divided by x. Negative 48. Then we can look for 2 factors that multiply to be negative 48 and add to be 2. What would those 2 factors be? And 8 and 6. Because we have a negative 48, we need one of them to be negative. Which one would be the negative? 6. 6. We have x times x plus 8 times x minus 6. Questions on that one? Did we have any questions on the first one? Because I meant to go back to that. For number 21, what do these 3 have in common? 4. So if we divide all 3 by 4, what's left? W squared. W squared for the first one. And then negative 13w. Negative 13w, yes. And then negative 3. So we would bring down that 4. And we're looking for 2 factors that multiply to be negative 30, add to be 13. This is negative, so one of these is going to be negative. What would those 2 numbers be? What did you say? 10 and 3 would multiply to be 30, but they would both need to be negative to get negative 13. And only one can be negative. So 10 minus 3 wouldn't give us negative 13, and the other way around also would. Yeah? 2 and 15, which one would be negative? 2. The 2, 4. would that give you a negative 13 if 2 was negative? Yeah. So positive 2, negative 13 would give us negative 13 and negative 30. Do we have any questions on that? Right. We're not going to do the other 3 because I want you to do them if you haven't. Not right now, but later when we have time to practice, you'll be able to go back to those. Look at the notes that I passed out to you. That looks like this. We're going to start those. Remember that this may be new to most of you, so all of you should be paying attention. So just to recap, all the different factoring methods that we've done so far. We've talked about factoring by GCF, factoring by grouping, which is GCF twice, factoring by difference of squares, which we have perfect squares, or GCF with difference of squares. Factoring trinomials when your A value is 1. This will be factoring trinomials when your A value is not 1. So whatever is in front here could be negative, could be positive, could be something that is not 1. So when we do this, some of what we've done before will come into play. Some of what we did last class will come into play. But it'll also be a little different. So I'm going to talk through the steps and then we'll actually do the examples. So for all of these, the very first thing you need to do is find your GCF. And then if you have a GCF, go from there. What could happen is you divide out the GCF and then we get the problems like we just did, where we're back to A plus 1. Or we divide out the GCF and then we still have an A that's not 1. And then we have to keep going. So after we do that, we're going to take the first and the last term, number-wise, and multiply them together. Then we're going to figure out what times what would give us that number. Yes. You guys don't have that. I knew I had a bunch of extras. Did I miss something? So find 2 numbers that multiply to B, whatever number you get. From there, once we find those 2 numbers, we're looking for whatever multiplied to get that, but adds to get B. So that part is kind of the same. And then you'll see when we do it, because the words right now probably aren't making a whole lot of sense. I'm just talking through it. And then we will use those to rearrange our polynomial so that we'll have 4 terms instead of 3. So we'll use grouping. So it already sounds like a lot. It kind of is. But let's actually do one so you see what I'm talking about. If this is not enough space, grab extra paper. Don't feel like you have to smush everything in that small space. Does this have a GCF? One. Do all of them have X? No. So not the X part, just 1. So I can say this does have a GCF of 1, but if I divided out the 1, that wouldn't really change anything. So that matters to some degree, but doesn't also. So because our GCF is 1, we're going to take the first and last and multiply those together. So 2 times 3 will give us 6. And we're looking for 2 numbers that multiply to be 6, but add to be 5. What are 2 numbers that multiply to be 6, but add to be 5? 1 and 5 would multiply to be 5, not add. 2 times 3. Yeah, you had your hand raised. 2 to 3, yes. So we can say 2 times 3 would give us 6. 2 plus 3 would give us 5. This is where it gets a little bit tricky. So we want to include these two in this polynomial. So what we're going to do is take the first term and the last term, rewrite them, and keep them in the same place. I'm going to put some space in between them. And then instead of rewriting this middle term, I want my 2 new numbers I found. We know 2 plus 3 is 5. So we're kind of splitting that middle term into 2 new terms. This middle term had an x, so when we write these two, they will both have x's as well. So I'm going to write this as plus 2x plus 3x. It does not matter the order in which I write these. It could be plus 3x plus 2x. If you want to put it so that you have certain numbers together, that's fine. It's not necessary. Now we have 4 terms, so we can use our grouping method of factoring to factor this. So split this down the middle. And then we're looking for 2 numbers. I'm sorry. Of the first 2 numbers, what do these have in common? 2 and x. So we're going to write that out front. If we divide both of these by 2 and x, what's left? X. For the first one. Say that again.
X.
We divided 1x out. So just 1. And then 2x divided by 2x. 1. So plus 1. And then what could we divide out of the last 2? 3. Remember that whatever this third term is, whatever sign it has, bring that down. So plus 3. If we divide 3 out of both of these, what would be left? X plus 1. Remember that these should be the same. So if those are the same, then everything on the outside is going to be one of your factors, 2x plus 3. And everything on the inside is going to be one of your factors, but they're the same, so x plus 1. So that would be your answer. To check yourself, you could go back and distribute this, make sure that you got the right things in the right order. So I could multiply 2x, and 1. 2x times x would give me 2x squared. 2x times 1 would give me positive 2x. 3 times x and 1 would be 3x plus 3. And if I combine all of your like terms, which is just the middle 2, we have 2x squared plus 5x plus 3, which is the original, so that works. I know that was a lot. What questions do we have on any of that? That process, how we got the answer, anything that you may have gotten lost or confused on? I did want to mention this. When you're thinking about these numbers at the beginning, if you want a way to organize those numbers and like you're not putting them in random places, you could make like an X. Whatever number you get when you multiply would be the number in the top of the X. So 6. Whatever your B value is would be in the bottom, so 5. So you're looking for a number that multiplies to be 6, adds to be 5, and then your factors that we found were positive 2 and positive 3. So if that helps you organize your numbers, use that. Don't feel like you have to use that, but you can. And let's move on to example 2. Does this have a GCF?
No.
So there's always 1. You can always have a GCF of 1, even if it doesn't have anything else in common. But that wouldn't change anything. So we can move on. We need to multiply 5 and 6. That would be 30. So we're looking for 2 numbers that multiply to be 30, but add or subtract to be negative 17. Think of your factors of 30. Of those, what could you add together to get 17? Negative 17. Remember, if you're not sure about your factors, start dividing. 30 divided by 1, divided by 2, divided by 3, 4. Keep going until you find all of your factors of 30. It is 15 and 2, but because 30 is positive and 17 is negative, the only way we would get 17 with 15 and 2 is if they were both negative. So if you make negative 15 and negative 2, then we can use those. So once you have those factors, you can rewrite your polynomials. First and last term stay the same. So 5m squared plus 6. Does not matter how I write negative 15 and negative 2. We just have to make sure we have our variable. So negative 15m minus 2m. Split it down the middle. What could we divide out of the first two? 5. 5, is that the only thing?
Yeah.
Okay. Number-wise, that's the only thing. What about variables? And m. So always be looking for both numbers and variables. What could you divide out of both? What do they both have in common? If we divide out 5m, what's left? M. Negative 15m divided by 5m minus 3, negative 3, yeah. And what could we divide out of the last two? 2, but it would be negative, because this is negative. And what would be left? 3 would be at the end. It would be minus and m. So what would our two factors be? 5m minus 2 would be 1.
M minus
and then n minus 3. Just to make sure this works, I'm going to distribute it back out. 5m times m would give us 5m squared. 5m times negative 3 would be negative 15m. Negative 2 times m would be negative 2m. Negative 2 times negative 3 is positive 6. Combine these two like terms and you get 5m squared minus 17m plus 6, which was the original. Have any questions on that one, Shakai?
So, let me try so when we have like 15 and 2 or negative 15 and 2, put that in where it's where it's 15. We found it from trying to multiply 5 and 6, but also the 5.
Yes, all of what you just said is correct. We found negative 15 and negative 2 from two numbers that multiply to be 30, but add to be negative 17. We take out the middle term and replace it with the two numbers we found. Any other questions? Let's do example 3. Does this have a GCF? Yes. What is it? 1. So because it's just 1, we can multiply 6 and negative 4. So we're looking for two numbers that multiply to be negative 24, but add or subtract to be negative 5. What would those two numbers be?
Negative 8.
Negative 8 and positive 3 would work. So I can rewrite my first and last term. 6y squared minus 4. If I wanted to put my 8 with my 4, I could, or I could just put it next to my 6. The order there does not matter because you're going to end up getting the same answers no matter what. So let's say I put negative 8y plus 3y. If you did it the other way, you'll see that we get the same answer. Split the middle. What can we divide out of the first two? 2 and y. What would be left?
3y minus 4.
3y minus, I missed the last one.
4.
What can we divide out of the second two? 1 is the only thing we could divide out because they don't have anything else in common. And that would make this the exact same. So then what would our factors be?
2y minus
2y plus 1 and 3y minus 4. So if you switch them, you may have needed to take out a negative. Otherwise, your insides would not be the same. So if you put negative 8 over here, you would need to take out a negative 4. Okay, let's distribute. 2y times 3y would give us 6y squared. 2y times negative 4 would give us negative 8y. 1 times 3y would give us positive 3y. 1 times negative 4 would give us negative 4. Combine your like terms, and you get 6y squared minus 5y minus 4. This is what we have. Do you have any questions? We're going to do one more together, then I'm going to let you practice some. Example 4. Do we have a DCF? 1. Right, because our DCF is 1, multiply 12 and negative 5. So we're looking for two numbers that multiply to be negative 16, but add to be 11. Be careful here, there's a lot of factors of 60. Yeah. Negative 4 and positive 15 would work. That would give you the negative 60 and add to be negative 11. So we could rewrite this. 12c squared minus 4c plus 15c minus 5. Split it down the middle. What could we divide out of the first two? Say that again. 2 would work, but it's not the highest. 4 and c. So we divide out 4, what's left? More c, sorry. 3c minus 1. What could we divide out of the last two? 5. Positive 5. And if you divide that out, what's left? 7 minus 1. So our two factors would be what? 4c plus 5 and 3c minus 1. Distribute this back out. We have 4c times 3c is 12c squared. 4c times negative 1 is negative 4c. 5 times 3c is 15c. And 5 times negative 1 is negative 5. So that would give us 12c squared plus 11c minus 5. So for the remainder of class, if we have time, we'll go over them. If not, that'll be the first thing we do on Tuesday. But for the remainder of class, I want you to try examples 1, 2, 3, and then you finish those, move on to the next page, and try 4 through 9. Stop after 9, don't try 8. We'll do that next class. Anyone have questions on what we're doing for the remainder of class? Yes. Great. You guys have this time to work. Let us know if you need our help or have any questions.